Ladies and gentlemen, this is Joe's Classic Video Games back with another cool pinball repair video for you this evening. We have been working on this 1979 Bally Star Trek pinball machine that was in really rough shape whenever we bought it. And we've done a couple videos on it. We stenciled it, cabinet back. We did some touch-up paint on the playfield. And in the last video, we were working on the power supply. Got that all kind of taken care of, the rectifier and the transformer. And we are now up to, we need to keep working through the back box. Hopefully, by the end of this video, we will have the MPU booted on it. Now, the original MPU is still in this thing. If you didn't see our first video, go back and watch it. I've had people lately say that angers them when I say that. People, I can't put it all in one video. And if you just look on our channel, go click our channel. And the video before this one is the previous video, so go watch that. If you didn't see that video, though, I can give you a quick rundown. We bought this from a guy out of a field, so it was outside exposed to the weather for quite a while and was all screwed up. So we're bringing it back, though. So this main MPU board over here is really screwed up. But we have a brand new one, so don't worry. Don't worry, people. Whatever you do, don't worry. So we got our rectifier board here working, but we didn't get all of the connectors connected back because one of them had broken. So the first thing we're going to do before we go any farther is we're going to service that. I'm going to put a new connector on here and then new pins in the connector on every one of those wires. And that is going to give me power to my back box so that I can get these lights on the back, right? Playfield lights are on, but we need to get the back box lights on. So I'm going to repin this connector. I'll show you how we do that. And then these two, sometimes you should repin those two. It just depends on how far you want to go with it. These are working fine, so I don't have to do it, but you can replace these connectors and reuse the plastic housings just so that you have a nice solid connection there on all of the voltages. So we'll look at that, see what kind of shape they're in, but they're all working at the moment. But we're definitely going to replace this one. So let's do that first. I usually order those connectors from Great Plains Electronics. There's a website, greatplainselectronics.com. The gentleman that runs that website is Ed, and he kind of collates things that are specific to pinball machines. So he sells those particular housings because on these Bally rectifier boards, those burn up a lot. So if you're wondering how that happened, basically this pin and the other one are the general illumination voltage, which is an AC voltage, 6 volts, which goes out and lights up the playfield lights that are always on that particular connector. It's the back box lights that are always on. So that's very common. If you get one of these, it'll almost always have that all burnt up. It looks worse than it is. It looks like, oh, there was a fire. It wasn't a fire. There was just a lot of heat from the amperage. Okay. So I'm gonna go get my stuff. I just go through with the power off, of course, and cut every wire, put a new crimp pin connector on the end of it, and slide it in a new housing. And then you end up with a brand new connector. Voila. Ready to go for another 42 years. So let me grab that stuff that we got from Great Plains Electronics, and we'll start swapping it out. Okay, so you can see the difference between the new. Look how nice. Look how beautiful and shiny. That's what you want. Look, I even got the little keying plug. That's the little piece that everybody's always missing. By the way, if you can't find one of those, you can put a zip tie in there. Like if you put a zip tie so that the pin can't go in it, works pretty good. And then here's the old. Look at the difference. It's like night and day. Now you might say, why are you putting it back exactly like it was? That's because that's what we do, but they usually had number 44 light bulbs in them, and we've replaced them all with number 47 light bulbs. So whenever you do that, it lowers the wattage and the amperage, and I guess makes it run a little cooler. So most of the damage that's done like that from heat is because when these first came out, you know, they were left on for a few years there at the beginning, and it screwed up a bunch of stuff. So once you fix it and you lower the wattage that it's handling a little bit, and then you use it less because it's in your house as opposed to out on location, usually it doesn't become a recurring issue. At least not that I've seen. But you know what? I haven't been working on these for 40 years, so I don't know. Here in a few years, I might have to redo them all again, but we'll see. So I just cut the wire off one at a time so you don't get confused, and put them right exactly where they go. And I just do them right here on top of each other. These are the crimpers we use. It's kind of a cheap brand, but it has a little jaw where you can put the pin up in there and then put your wire in there, and then watch this. Like, it won't let go until you get it all the way crimped, right? And then it opens up. They call those ratcheting crimpers. That's the kind you want, I think. They are driving me nuts on this freaking text message. I'm going to go check here in a minute. That's the type you want because it gives you a perfect crimp every time. Easy peasy, people. There's nothing to it. Get the pins and the connectors at Great Plains Electronics. We don't even know Ed, but he does such a great job. That's where we always send people. And then if you want a pair of inexpensive crimpers, just like we use, go check on our website. Go to lionsarcade.com. We've got a parts page with a bunch of the parts and tools and stuff that we use on our repairs. A lot of that stuff is links to Amazon, so if you go to Amazon through one of those links and buy anything, like if you buy your own Star Trek pinball machine on Amazon, it gives us a percentage of the sale, so we appreciate that. So I'm going to finish up that connector and then put it on there, and I'll check the other two to see if any of those pins need replaced. You can do them the exact same way. And then we're going to be finished with the rectifier and move up here to the voltage regulator board, which is just the next in the powertrain. We're just working through the cabinet from the wall to the transformer to the rectifier board to the voltage regulator board. Let's get that new one installed. Now, before I plugged it back in, we've got the regulator board unplugged because we don't know about the voltages on it yet. And for the first time in a long time, the back box has some lights that work. The ones that don't work, most of them are just missing. Okay, so next up, I'm just going to swap all the light bulbs. Now, we had a viewer ask us how to change the ones that are sunk down in here. On this particular one, you can get to all of them with your hand, really. But the way you do it, if it's in a situation where you can't get to the bulb, is you use a shooter tip on the... I don't have the ball shooter in here. Look, there's no shooter. You use a shooter tip rubber. It's the perfect size to grab one of the bulbs. So, and it'll allow you to remove it, and then you can use it to put one back in. Old school stuff, people. All right, so I'm going to swap all those out real quick, and then that'll pretty much finish our problem with the GI lighting that we were having, i.e., none of the ones on the top were working. Much nicer. All right. So we got that done. Now we're on to the regulator board. So I'll go ahead and pull it out, and we'll check it out on the bench. Got to do a few upgrades to it. So here is the Solenoid driver board. Same one that's used in all the early Ballys and all of the early Sterns. Slight differences between different models, but they all do the same thing and wire up the same way. So power comes in here, 12 volts from the rectifier board that we worked on in the last video. This regulator here changes it into 5 volts. I've had people tell me that's not a regulator. This transistor here works to change it into 5 volts. This is the high voltage area for the displays. So it takes it's 175 volts whenever this board's not plugged in, but I think it goes up to about 250 volts. It takes the 250 volts and then allows you to adjust it down to like 180 for the displays. Okay, that's this area. Okay. And then the bottom half of the board runs the solenoids. So they call it the solenoid driver board. Okay. So this connector gets signals from the MPU, which goes to this big old 74-154. I think that's what it is. Did I guess that right? Yes. 74-154. Look at that. That's high def there, people. It goes to that, which sends out, it controls these little, whatever you want to call these. Let me see if I can get a part number on those for you. I know you folks really love these part numbers. It's a CA3081. Let me make sure I'm reading that right. Let me look real close. That's what I'm seeing. CA3081. You know, I've never had to order one. I have had a few of those go bad, but whenever they do, I take one off a parts board. Okay, and then that syncs the transistors. So if one of these transistors turns on, it connects ground to the pop bumper or something, whatever they've got wired up to it. So some of them are standard in each machine, but then there's a bunch of extra ones that they never really used. I don't know if there were any of the early Ballys that used all of the solenoids. So you've got, I think, 4 or 5 of them control the soundboard, but they don't really use the, I don't think they use the actual solenoid. I think it's just a signal from the MPU. I don't think they actually need the transistor. So you got like the out hole, 3 pop bumpers, 2 kickers. The flippers don't have one, but there is one that turns on the flipper relay up here to turn on the flippers. Right? And then let's say there's a like a scoop somewhere that pops the ball out, or maybe there's 2 of them. Okay? Well, we've got plenty left. So maybe it's one of the early boards with chimes, so there's 3 chimes. Or maybe it has 4 chimes. You still got extras. So it was a pretty cool little board. It had plenty of extra stuff to make things happen. Okay, so the first thing that I do whenever I upgrade them is you got to get rid of this filter capacitor. This thing's a big pain. So it's a, I hope I didn't run out of these last time. It is this particular one is an 11,000 microfarad 25 volt capacitor. And basically what happens is over time that starts letting some AC ripple through. And it makes it where the voltage regulator can't give you a nice clean 5 volts. So that's a good thing to replace. So we're going to do it first. Well, I'm out of the filter caps, so I ordered some. By the end of the video, I'll put one on, but you get the you get the whole thing. Well, that'll give us an opportunity to test this one and see if it's bad here in the game here in a little bit. So you want to do that first, though. Swap that, and then the next thing that I do is I reflow the solder on the pins around the edge. These things will get cold solder joints, and especially around the ends of the connectors. I can't tell on that one. You see any rings around them? Especially on the ends. That one looks pretty good. Not too bad. Remember, yeah, there's some. See those first 3, 4? Those first 4? See how they have a ring around them? Look at that. Look at that. That's definitely an issue, people. Definitely. Look on that end, too. That whole freaking connector's about to pop off. That ain't right. We gotta fix that. I see bad solder all over the place. Okay, so I'm going to fix that. So I'll show you how I do it. Or I'll tell you how I do it. I take a wire brush. And basically you're getting all of the dirt and crap off of them. Hit them with the wire brush. And then I do not remove the old solder. If you've got a situation where you're taking the connector off or something, yeah, you can do that. But it's metal, people. When people tell you that stuff is bad and has to be removed and then new put on, they are lying to you. It's metal. Listen to whatever their argument is, and then I'm going to refute their argument by saying it's metal. And they're going to say, but the flux, it's metal. They're going to say, but there's contaminant. It's metal. You're flowing some extra metal on there to make a good connection. It's cool, people. Now, if you want to take that metal off and throw it away, that's fine with me. It's your own game. Do whatever you want. I'm just telling you, you don't have a leg to stand on in this argument. It's metal. Metal conducts electricity. I think sometimes people get too brainiac for their own good, okay? Metal conducts electricity. This is a metal trace, okay? The metal trace connects to the metal pin with metal that we call solder. Some of you call it solder. Okay? So we're connecting the two with metal. You don't need to take the old metal off. It's just cracked. You just need to make it where it sticks again. I can't wait to read the comments on this. It's the truth, people. Look, I only tell the truth. All right. So I'm going to get the dirt off of there. I'm going to flow a little bit more solder on there. I had a guy send me a message and say, hey, man, I keep hearing competing viewpoints, but you look like a guy that just tells people the straight dope. Doesn't give people any BS. Do I need to remove the solder or do I just add a little more? You just add a little more, people. Don't listen to the people that want everything perfect, okay? If you try to make everything perfect, you're going to be here longer than me ranting, slowing down this process. Okay, so yeah, I'm going to go through and I'm going to clean them up a little bit, and then I'm going to add just a little bit more solder, and then I'll show you the finished result. Okay, so I just added a little more back in, reflow it, get it where everything's making a nice, good connection. The problem you'll have if you don't clean it off is you'll get like a little ring around the post. That's basically dirt. It just doesn't flow as good if you do that. But we're good. We got it. All right. Now, another thing that people tell me all the time is that if I repair a trace, I have to put the conformal coating back on it. And they tell me all of the most ridiculous freaking stories that you have ever heard. Now, I've been trying to be nice about it but here's the thing. I'm not going on somebody's video that's using conformal coating and telling them they're doing it wrong. No, I don't care how they do it. They should do it how they want to do it, right? They're coming on my video and telling me I'm doing it wrong, right? The whole thing is just ludicrous to me. So here's their ridiculous reason for why you need to put conformal coating on it. If you don't, the trace will deteriorate and it's not up to spec, which I find laughable, right? If the copper is exposed to the freaking elements, like air, if the copper is exposed to the elements, it will deteriorate and the life of the board will be shortened. They tell me some variation of that nonsense every time, right? Let me tell you why people put conformal coating on it. Because it looks pretty. That's why. Okay? Look at this. This is a 40-year-old board with exposed copper traces because that's how it was designed, people. There's nothing wrong with having exposed copper to air. Anybody that told you that told you a bunch of nonsense, okay? The wiring in your house, it's all copper. None of it has a conformal coating. Every time it hits a switch, a freaking plug in the wall, a socket. Had people tell me I can't call it a plug. A receptacle in the wall. All of that has exposed copper. Now you could argue that that's thicker copper, right?
You could argue that. But nobody is doing load tests on these freaking traces to see if they're thick enough to handle being exposed to air. Come on, people. Come on. The copper doesn't break down. And people, come on now, people. We got to get this together now. You got to stop with the bullshit, people. I mean, it has got to stop, people. The copper does not deteriorate in the air. All right? That's not going to happen, people. We're going to be just fine with copper exposed to the air. I don't know who's telling people this crap. If you want your board to look real pretty, you can take conformal coating and paint it over this crap where they didn't put it at the factory. If you want to, but moving right along. Oh, no. Hold the phone. You're not going to believe what I just saw. Would you look right there. There's a spot from the factory where the conformal coating came off. Well, this thing's trash. Heck, I'll never be able to use this board again. There's a little bit of exposed copper there. You know that trace isn't up to spec now. That's not the right amperage trace now. Oh man, what a letdown. I guess I could try to wing it for another 40 years and see what happens. Conveniently, that's actually one of our next upgrades. I did not do that, but it's in the perfect spot. So this ground to the filter cap, it helps if you kind of tie some of the grounds together on the board. So one of the things that we do, that ground from the filter cap, it goes back and it goes out one pin on the connector. So if you have any resistance on that pin, you get a flaky ground to your capacitor. But by the way, this is a one-sided board. This side has no traces on it. There's some jumpers. Right? So if you tie that ground into the other grounds, now you're a little beefier, right? You've got a better connection here at the board. All right? And a lot of people say you shouldn't do that too, but I'm going to stop arguing with people about what they say I'm doing wrong. I just like the funny ones. The ones that are funny to me, I like bringing up. Okay. So one of the upgrades I do, you don't have to do it, is I connect the ground to the ground on the board. Okay. Now, all of these upgrades, I got these from Clay at penrepair.com. That's where I learned to work on all this stuff, was reading all of his wonderful walkthroughs where he shows you how to fix this stuff. So Clay does it, and that's good enough for me. I've done it on tons of pinball machines, haven't had any problems, so that's what I like. Okay, so I'm going to do that little upgrade. I'm going to put a jumper from there to there, and then at the same time, there is a capacitor up here. That is the filter capacitor for the display voltage. Okay, it's the same thing, right? That one you don't necessarily have to replace unless you have issues. If you have issues, you'll start getting a flickering on your displays where they're doing weird stuff, right? If it's doing that, sometimes it's that capacitor that needs to be replaced. But even though it's 40 years old, it's not as critical as the one for the 5-volt regulator because you've got every IC chip in the game working off of that, right? So if this one's got problems and you're getting ripple on the 5-volt line that the regulator's creating, right? You're going to have problems where the game resets. And boy, that's annoying if a game resets right in the middle of you playing it, or it doesn't always boot up or whatever. So you have stability issues if that one's a problem. If this one is a problem, you have issues with flickering displays and stuff. Okay, because the displays are just, they have a decoder chip that gets its 5 volts from here, right? So they have a decoder chip that actually runs them, but the actual displaying of the digits, the high voltage is coming from here. Okay, so we also work on the ground on this one. So here is the ground. See how it's on one trace? Just think if that thing, just think if any of the copper gets exposed there. Boy, we'll really be in trouble. That one trace comes around to here, comes around to here, and then the same thing. It's just connected on one pin off of the connector. If you get any kind of resistance on that, look, they're all dirty now because I haven't cleaned them yet. If you get any kind of resistance on that, you get problems. So when it goes back, it ties to the ground on the regulator board inside the back box. Not the regulator board, the rectifier board inside the back box, okay? And then when this one goes back, it ties to the rectifier board inside the back box. And then the ground that's on the PCB also ties to the rectifier board inside the back box, but it also connects to these ground traces with the exposed copper around the edge, right? So whenever you tighten down the screws, you're basically connecting the ground on this board to the ground plane in the back box. So what I'm doing is, instead of having the filter cap go back and just connect at the rectifier board, which is grounded to the back box, or to the ground plane of the back box, I'm going ahead and grounding it here on the board and on the screws. And we're tying all of the grounds together all over the freaking place. Okay? And the same thing with this one. So I'll put a couple little jumpers on that, and then we'll move on to the next thing. So we've now tied the filter caps ground to ground on the board and in the back box, right? And we've tied the displays ground to the ground in the back box. Well, we got a good ground connection down, don't we? Your argument against that would be that you don't want the ground connection to be that good. That's the only argument you got. People have tried to tell me it's a star ground system and all this. It's nonsense, people. The rectifier board is connected to the ground plane in the back box. This is connected to the rectifier board. Okay, this one's connected to the rectifier board. All I'm doing is making it where that connection's stronger. Don't worry about it. It's going to be just fine. All right, and I've also had people tell me recently that to clean off the flux. Oh, clean off the flux. It'll destroy the board eventually. It's the same thing, people. If you want to argue that you should clean off the flux because you want it to look pretty, I understand that argument. Yours will look prettier than mine. And there's nothing wrong with removing the flux. But they put the flux in the freaking solder. If it's in the solder, it's not harmful, any more harmful than the solder is. You can argue this all day long. I'm just saying, I'm not going and arguing it with them. They're coming over to me. They're attacking me on it. Come on, people. Come on now. People, the solder, people, come on now. The flux is in the, if the flux is inside of the, it's in the, I'm not even putting it on it. It's in the solder, people. If the flux is in the solder, come on, people. I can't clean it out of the inside of the solder. Come on now. Come on, people. We got to stop all this, people. Come on now. Okay, so next thing I'm going to do, I'm going to clean the pins. I hope you guys all know, and girls all know, I'm just playing around, okay? Don't. Just take it easy, people. I got to clean all the pins to make sure there's a good connection on everything. You can, the same thing with this. You can replace all of these if you want. So, you know, there's one of the hardest things to explain in these videos is, if you're a hobbyist and you have one pinball machine and you want it to be top notch, spend a little more time, spend a little more money, and it's just a little more money, and just take what I'm talking about and take it to the next level if you want. You can replace all these pins because it's just a couple bucks, right? You can do, you know, 100 things to the next level of what I'm doing it, but I'm doing it and charging somebody for it, you know. So we're doing it to the level that we think's appropriate and that we usually get good results with. But if you want to do it for your home and you want it to be even more bulletproof, you can go a little farther if you want. But I usually don't replace these connectors because I usually don't have them where they have failed. But they do get filthy, so you got to clean them up. So I'll clean them usually with a file, or you can use, you know, light sandpaper. You just want to clean them up, get them where they're nice and shiny again. But if you want to replace them, put brand new ones, that's fine too. I think it's a little overkill though. Okay, so I'm going to clean all of those, and then we're ready to test them. I'm also going to go ahead and replace this, whatever the crap it is, because it's so rusted, you know, I'm not going to roll the dice on that. I think that's an LM323 if I remember correctly. Let's see if I can clean off the rust. Here we go. We're going in. I can't do it with one hand. Okay, now you might not be able to read it, but I could read it. Let's see, maybe I can get it just right. If the light hits it just right, you can read it. It's a 74H05. I mean, I'm sorry. It's a 78H05. Big difference, you know. Can you see it? Can you make it out? It's right in the middle there. It's still holding on. So it's a 78H05. We just went through this in I think in the $6 Million Man, we figured this out. Okay, so there are three things here. So there's the 7805 voltage regulator that is basically it takes 12 and makes 5 is what they use it for. But the 7805 is only a 1 amp regulator, and that ain't enough. So they didn't ship with those. They shipped usually with LM323s. And LM323 does the same thing, but it's a 3 amp. So the 3 amp one was enough to power everything. When people replace those, and from the factory, because it's written in the manuals, sometimes they shipped it with this. A 78H05. Okay? So the 78H05, the H makes all the difference. That makes it a 5 amp version. If it doesn't have the H, it's a 1 amp version, but I don't know that it would even be in this form, you know. So you gotta put a 78H05 on it. So that's what we're going to do, which is what's in it. So we're going to take it out, swap in this one, but I'll test that one just to see if it was still holding up after all this time. After all the time out in the trailer in the field, and it survived that night that Bubba shot the pinball. If you don't know about that, you need to go back and watch the earlier videos. Bubba shot the pinball last night, 20 years ago. Okay, so let me swap that out, and we'll test that one too on the bench and just see if it works. Okay, so I swapped it out. There's the old one. The only reason I'm swapping it is because of all that rust on it. It's probably still fine, but what can you say? So the way it works is it gets 12 in here, which also runs over to the filter capacitor. Okay, and then it has a ground here with exposed copper. This is a cap between ground and 5. This is 5, right? And then right here is a resistor connecting it to ground. Okay. And then this is the 5 output. It goes to this is a test point on the other side, and then it runs out through all of these pins coming off of this board because it needs a wire for the MPU to get 5 volts. It needs a wire for the displays to get 5 volts. It needs a wire for the lamp driver board to get 5 volts. It needs a wire for, I think that's it. Oh, and it needs one wire that comes out and is a jumper wire, comes off the board, and then back on the board at this last pin. Well, this last pin often gets a bad connection because it's at the end. You know, so the ones at the end, like we talked about earlier, get bad solder joints, right? Which you fix whenever you resolder it. But there is just a little jumper on the connector to send the power back in here. And people have told me that's because of how they use the test fixtures at the factory. Could be. So the 5 leaves here, goes off the board, and then right back on the board right here, and comes down here, and it runs all of this bottom half of the board that we talked about that runs all the solenoid drives. So those 4 chips need 5 volts. Okay? So another upgrade is you just put a little jumper from your test point on the 5 to the test point. This is the test point for, hey, did the 5 get to the bottom of the board? Right? So I put a little jumper on that too, just so that it's always got a nice solid connection to 5. Especially since it's the solenoids. The 2 things you want to worry about in the game is the displays burning up because they're high voltage, and then the solenoids locking on because it burns up solenoid. Okay, so swap that in. Oh, I need to test that one. That's right. Swap that in, put the jumper What are we left with? We need to test our high voltage. Another good little upgrade to do is to replace, so that's the voltage regulator. Need to replace the filter cap. Another good thing to do in this high voltage area is this potentiometer is often crap. So you turn it and it will allow you to set the voltage from, I think you can go down to about 160 and up to 200 or something. You want to be about 170 or 180 on your displays. Just it makes them last a little longer. But these, it's just a crappy potentiometer, so they get screwed up a lot, right? So that's a good thing to replace if you're in here replacing stuff. Check your fuse. If your fuse is blown, you're going to have one of these two transistors is probably bad, or both, and you could have some bad diodes. You have a diode here and a diode here. Okay. Sometimes you also get some burnt resistors, but this looks fine. Nothing, I think everything's cool. There's not really an upgrade here, with the exception of that potentiometer. And strangely enough, this little heat sink that they've got wrapped around that transistor, they don't usually have one on this one. It seems like it's always on that one, but not on this one. You can see they even laid the board out like that. So it must be that one gets the brunt of. But usually you don't have to replace those unless your fuse is blown. So I'm going to check that. That's like a 1/4 amp fuse or something like that. Here's the circuit, what you can make of it on the back. Now your larger one here usually isn't the problem. And you can check these in circuit. The base and the emitter on this, I believe, show shorted or something like that whenever you check it. Let me grab my meter and we'll test some of this stuff instead of me just talking about it. And it'll be a little easier to show you how it is on my board, and then you can see if yours is like that if you're working on yours. Okay, my arm's probably going to block some of that meter, but you'll figure it out. So, we can test things like, for instance, the fuse just from the back, So this is the fuse holder. Whoa. Gotta do better than that. That's not good. That fuse is probably blown. Nope, that's fine. I just can't test it from the back for whatever reason. I guess that stuff's too dirty. Let's see if we can have better luck on our transistors there. Okay, so it's actually screen collector base emitter. 0.5, that's good. 0.5, that's good. So that one seems to be fine. If one of them tests fine, the other one always tests fine because of the way they're arranged. One of them can't really go bad without making the other one test shorted as well. Okay, so that one's a little different, 0.6, but it's fine. If it's between 0.4 and 0.7, usually you're good. And then over to here, 0.3, 0.213, 0.213, 0.113. I am not convinced that's good. Yeah, I don't, let me see, maybe it's because I'm using the 0.3. Yeah, I think that's probably bad. I don't like the numbers I'm getting, but it's in circuit, so it may be fine out of circuit, but we're about to find out because I'm going to pull it out of circuit. So let me remove that one, and then we'll test it. So basically I'm getting, no matter which way I test, I'm getting 0.3, 0.1, 0.2. You should have a 0.4 to 0.7
window there for the voltage drop. Sometimes in circuit, though, you can't test it like that. And that one, I remember that when you test it in circuit, there's something a little fishy about it, but everything I'm testing is giving me low numbers, so I think there might be something screwed up with that. So let me pop it out and we'll check it out. Okay, I figured it out. There is a diode. One of the diodes is across the emitter and the collector. And so if that diode is shorted, as this one, it wasn't completely shorted, but it was getting there, then it'll give you funny test things. So you see now I've got 0.505, and then to this side I've got 0.212, but that's what I was remembering. So you can get a good reading one way, but you won't to the other side because of some resistors and stuff that they have in the circuit. Okay. So I need to replace this diode. Whoop. If I can tell what it even is. Manual time. We'll figure it out. Okay, folks, looked it up in the manual. It's a 1N4004. Swapped in a new one. Checked all of the resistors. None of them are out of spec, and none of the 3 transistors seem to be bad. So, seems like that the diode was down to 0.1. So, it seems like it was shorting. It was about to blow up, but we caught it just in time before it smoked anything. The fuse, I cleaned it and put it back in. Its testing is fine. It is a 0.187. That's interesting, but that's what it is. So I guess that's about That's a weird number. Why would they do that? So it's not quite I guess that's a 1. That's a, let me do math. Is that a sixth? It's 1/6. Is that right? 6? It's interesting. It's supposed to be a 3/16. I guess that's what that is. No. Yeah. It's a 3/16 of an amp fuse. Okay. I replaced the potentiometer. Okay. And then nothing else needed to be done here in this section. So I think we're good, but we'll see whenever we power it up. We're going to test it. And then down here, I went through and I tested each one of these transistors with my diode test, just compared them to each other, testing the going from base to collector and base to emitter. And they're all identical. So I don't think any of them are bad. So I think everything's cool there. Of course, I cleaned the pins like I talked about. We've got our new voltage regulator there. We're waiting on this, but we're ready to pop it in and test it out. So let's see what kind of voltages we get out of it. Okay, so we're going to check some stuff. So the power comes in, goes to the transformer, goes to the rectifier board, and now we're up to here, okay? But the thing is, this is the board responsible for making the 5 volts, which, like I said, runs to everything else, with the exception of the soundboard. I think it has its own 5-volt supply, which is weird, but, well, I guess probably for noise purposes or something. But if you're going to test this in the board, in the system like this, you need to unplug everything, so just in case this isn't sending out 5 volts. What if it's sending out 10 volts? Then you fry all the chips on your MPU, you fry all the chips on your lamp driver board, and you fry all the chips on your displays. Well, in this game, all the displays have already been removed. We've unplugged the MPU, which is going to be trash anyway. We unplugged the power to the lamp driver board, and I unplugged the power to the soundboard, but I think it has its own 5-volt supply. Okay, so we're going to test it. We have this one connector up here, which is sending the power from the rectifier board up to the regulator board, okay? And so the first thing we're checking, this is our ground test point. I'm testing the positive lead of the filter capacitor, okay? So remember, we tied the ground of the filter capacitor to the ground of the whole board, right? So I'm testing across the 2 legs of the filter capacitor. So I'm connected to ground, which is connected to the ground on this, the way we've got it, and then I'm connecting to the positive. And I've got it set on AC. So at AC, we've got, it's bouncing around because the connections aren't that great with my probes right now. But we're down at 0.14. That's your AC ripple, basically, on the DC supply. If you're below about a 1/4 volt, you're cool. Sometimes you'll check these and they'll be like 1.5 volts or something AC on it. You don't want that. So we've got 0.1 volt AC coming through on the DC filter capacitor. That's fine. So if it's 0.250 or higher, about that, you want to replace it. You can also test in like an Atari arcade games. A lot of times, you replace the big blue capacitor in the bottom. That's the same, basically the same thing. It's creating the 5 volt or filtering the 5 volt supply. You can do the same on that. If you test AC across the two leads on the capacitor while it's powered up, if you're getting more than about a quarter volt or maybe a little higher, it's time to replace it. So this one doesn't have to be replaced, but I've ordered new ones, and whenever they come in, I'll replace it because we just always replace that. Okay, so that's our filter capacitor. Let's switch it over to DC. Okay, so we're still on ground. And so the first thing I'm going to do is test this top test point. Test point 5. So test point 5 is where the 12 volts comes on the board. Now remember, this is unregulated. 12 volts. If I can. So we're at 15.2 volts. So that's what's coming to the board. And then the new 78 H05 chip that we put in is regulating that down to trying not to slip here. 5.11. That's perfect. Sometimes that's too high, and you can change a resistor there or get rid of a resistor to fix it. We did that on a couple videos now. This test point 3 here will be the same because remember we put a jumper on it. So you're getting 5.11 volts to all of your chips on the bottom of the board as well. Okay. And so now here's the fun one. The voltage getting to the display voltage is 257 volts. Okay, and then it is turning it into 187 right now. A little bit high. Originally, the original voltage was called the 190 volt display, so that's about how they wanted it at the factory. But like I said earlier, we try to turn them down a little bit so you're running 170 to 180 to the displays. It just makes them last a little longer. But here's the kicker. We're not going to put original displays in this board. I mean, in this game. We're just going to put LEDs. So I fixed all that and everything, but we're not even going to use it. The LED displays run off of 5 volts, so whenever we get ready to do that, we'll remove the fuse from it up there. And I just fixed it because the guy may want to go back. The day may come whenever people are leaded out, and they're tired of the leads, and they reinvent a nice plasma solution that runs off of 190 volts again, and they want that to work. I doubt that'll happen, but hey, if we can fix it, why not fix it? I like selling them where all the stuff's working. Okay, so there you go. So our board here is fine. We're ready to plug up all of the other stuff. Okay, there is no way this MPU is going to work. I mean, it's about as bad as it gets. It's still got the battery on it, and it has corroded the bottom third of the board. All of the chips have rust and everything all over them. But just to humor you, I'll try to plug it in with the board. I understand you want to see it. Somebody left it laying out in a field for years and years and years. Does the MPU still work? There's no way, but maybe we'll see if the LED will even still come on. Right? So let me plug it up and we'll try. Okay, folks. So there is an LED down there in the bottom of that board by that white battery, and so there's no way the thing's going to boot, but we'll see if it'll even turn the LED on anymore. Okay. Nope. Nothing. Let me It's so corroded, I mean, it's probably not even getting power to that. There we go. All right, so there you go. We got the LED to at least come on. So it's getting 12 volts to the board is basically what that means. But that's about all she's got in her. Now we save really damaged stuff all the time, but this one is so bad, we're not going to save it. We're going to put a whole new board in it. So stay tuned for that next time. So I hope you enjoyed it so far. She's coming along. Make sure to leave your comments down below. Give us a thumbs up. Hope you enjoyed all of the friendly banter. And remember, folks, live long and prosper.